So today is one of our sort of few and brief chances to talk about what I call moderating or interacting factors. So we've talked about a bunch of different types of resources and some of the dynamics they have with respect to forest and outdoor recreation and managing that stuff. And when we start to sort of group multiple types of resources together, so a vista site, for example, needs topography, it needs clean air shed, it needs transportation infrastructure in the form of roads or trails to get folks to that beautiful, pretty spot. All those things kind of have to hang together, and if any one of them is degraded or missing or not safe for your visitors, then it's not a high-quality recreation opportunity, and we're not doing our best job. So today we're going to talk about some more interactions and combination type effects. We're going to talk a little bit about climate change and sort of planetary carrying capacity degradation, not as a specific class of resources, but as a bunch of factors and cycles and processes that touch kind of all of the different classes of resource that we have. So for example, the National Park Service runs a couple of historic sites on islands off the coast of Florida, in the Caribbean, and so forth, like old military forts made out of brick and stuff like that. Well, the ocean has risen several inches in the last century and is continuing to rise and is indeed accelerating at the rate at which it does that, to the tune of, I think, on the eastern seaboard of the United States, it's not quite a millimeter per year, which is just a stupefying amount of water, liquid water getting added to the oceans to be able to raise it even a fraction of a millimeter. And so, we get some pretty dry, bloodless statistics to kind of help paint that picture. So what we're going to do today is introduce some of these ideas, and then for each of you in your groups, the goal is to reflect on what is this particular statistic or factoid with as much context as we can give it today. What does that potentially mean for my park and management of it? So preservation is in some ways a responsive goal. That is, we are responding to deviations in current conditions from what we think it used to be like when it was more natural or in its original unmodified or unimpacted state. Right, we're trying to get back to something. But in Dr. Akamani's classes and so forth, we have to start wrestling with ideas like resilience. Instead of getting back to something that may not physically be possible to get back to these days with changes in the environment, how can we make it so it's at least as bomb-proof as possible against future changes, so we don't move it any more away from what it used to be, what the original goal was for preservation. Okay? Does that make sense? Cool. Before we jump into that stuff, any announcements for the good of the cause? Any questions about our upcoming field trip in a month? Any announcements about RSOs doing stuff, maybe around town this weekend, or?
What's the date of the field trip?
It's the first weekend in November, so it's like the, 4th, 5th, and 6th, something like that? So Friday, Saturday, Sunday, we're heading over to Mammoth Cave. It'll be pretty sweet. And if you're like Jack, bring a hammock. You can hammock camp. It'll be good. All right, so is that a Hayao Miyazaki shirt?
It is.
We're going to some Princess Mononoke themes. All right, so here we go. All right, so our world is not the garden planet, not the garden climate that it once was, that your grandparents, my grandparents grew up with. We'll back things up about 10,000 years to the major sort of detectable shift of humankind from hunter-gatherer societies, for the most part, over towards like row cropping, vegetable agriculture, and specifically animal agriculture. When you look back through climatological records, across human timescales and recent like ice age cycling timescales, concentration of greenhouse gases, primarily carbon dioxide, but also things like methane, fairly stable over a very long, like approaching geologic timescale. Right about the 10,000 years ago mark, so about 8,000 BC, people start domesticating and breeding beef cattle and goats and sheep and that sort of thing. And we see just a steady, sharp increase from that point. And then we get into like coal-powered stuff in the early Industrial Revolution era in the 17 into 1800s, and steam power and stuff like that. And that steady, so flat ramp of increasing greenhouse gas concentration in the atmosphere, it starts to accelerate, starts pitching upwards, opening up towards infinite. And that has continued. So, in my lifetime, I was born in 1980. I know I'm super old. Please don't hold it against me too much. But a majority of all of the carbon emitted by human activity has been emitted since I was born. So we are growing up in a world that is rapidly diverging from what all of the previous human generations ever, like back to the 140,000 year ago mark with modern humans, to the 350,000 year ago mark with pre-hominids and stuff like that. Like they did not experience what we are experiencing right now. We are out past the outer envelope or the edge of the range of conditions that people previously experienced. And it's subtle. It's a couple of degrees between about 1850 and now, a couple of degrees Celsius on average around the surface of the planet. But what that equates to is stuff like some of these statistics we'll hear in a sec, like the equivalent of 2 Hurricane Sandys of thermal energy trapped as excess heat from the sun that would otherwise be re-radiated out to space per second, or 5 Hiroshima-grade nuclear blast detonations per second in terms of just the heat that the ocean is trapping. And the oceans are absorbing about 90% of the excess heat. So, water has a very, very, very high heat capacity. It takes a tremendous amount of energy, like on the order of hurricanes and nuclear weapons, to heat it up when you've got a fairly big bowl of water like the Atlantic, plus the Pacific, plus the Southern Ocean, plus the Indian and Arctic and all that. Okay, so that's a lot of excess heat. All right, a couple other stats, and again, these global stats are interesting and they're valuable for hopefully galvanizing us into some useful action, but they're also global, which means we're going to smooth out a lot of the important variability. We're going to obscure a lot of much more serious effects by averaging things out globally in these stats. So, for example, the surface of the planet above the Arctic Circle, above 60 degrees north, and the Antarctic Circle, 60 degrees south, up to the North and South Poles respectively, that's heating up way, way, way faster, right? So we've hit a couple of degrees warming so far. Up there, it's like 6 to 7 degrees warming already, okay? So the growing season in central Canada is several weeks longer than it used to be when I was born already. Things are rapidly changing, and the effects tend to be more pronounced the higher north you go, the farther south you go away from the equator. All right, so here we go. We would need, on average, 1.77 planet Earths to sustain our current demand for resources and to absorb our waste. That is our overall ecological footprint as a species. If we tally that up as everybody living an American standard of living, with access to cell phones and cheap fossil fuel based electricity and stuff like that, our standard living is a lot higher than pretty much everybody else's in the world. Like, we spend energy more easily, more freely. We do stuff like drive our Jeeps and Humvees up cliffs because it's super fun, more than most people do in most other cultures. So, if we raise everybody up to an American average standard of living, and the energy we consume, the resources we consume in terms of irreplaceable soil loss and stuff like that. We need 5 planet Earths, more than twice as many as we need for everybody on average right now, okay? 5 planet Earths. Between a third to about 2/5, about 40% of the food that we produce in the United States or consume in the United States is lost to spoilage, to people throwing a bunch of stuff on their plate and then not eating all of it, like not going for the bonus fry at the bottom of the bag, just throwing that out. So there's a lot of inefficiency in the resource harnessing that we do have. And there's a lot of good research going on with improving spoilage, packaging, sterilizing the surface of foods against rot, that sort of thing. Lots of different ways we can tackle that. But the underlying fact is we still waste almost half of our food. All right, let's see. Around the planet, we are sacrificing 30 football fields a minute, or 12 million hectares of tropical rainforest each year. Around 30 football fields a minute. Around sometime in the 2030s, there are going to be more dead people on Facebook than live people. Around the year 2050, the year, we may see more plastic in the oceans than fish biomass. Which, or I should say current fish biomass, because, let's see, by 2048, 2 years before that, on our current trajectory, there will be no more commercially viable saltwater fish in the ocean. Saltwater fish just run out from being overfished. So 2048, not that long from now. Let's see. 2030, in 8.5 years, 8.25 years, the IPCC Intergovernmental Panel on Climate Change predicts that the worst impacts of climate change could be irreversible by then. Half of the world's coral reefs are already dead, and they have died just in the past 30 years. So, for the last, tens of thousands of years, lots of coral, and then in 30 years, we dropped from 100% to 50%, and a lot of these things that are causing coral reef bleaching are accelerating, so it may take us less than 30 years to lose the remaining 50%. We as a species are dumping about 1 dump truck of plastic into the ocean per minute, 24 hours a day, all year. And by 2050, 30 to 50% of species could be gone from the face of the planet.
How is that plastic getting in there? Is that just random boats, or are they legally allowed to dump into water?
So, even in the United States until fairly recently, I guess there's still garbage cows dumping trash. Instead of landfilling it, you just dump it in the ocean. Yeah, that's the thing. But for developing countries that don't have the infrastructure to burn a heck ton of diesel fuel to get all of our trash into a landfill, it's a lot more economically viable for them to dump it in a river, and the river washes it out to the ocean. So if you want, I got a couple of videos we can take a look at later of if it were substantial enough, you could walk from one side of lots of rivers in the world to the other and not get your feet wet walking on trash floating down. Let's see, every 48 hours, a forest the size of New York City is destroyed. Let's see, 1 in 4 species are already at risk of extinction. 16 tons per minute of sewage goes into American waters. 16 tons of poo, and those non-flushable plastic wipes and urine and the sebaceous, the oils that we wash off our bodies with soap and shampoo and then add it back in with conditioner. Stuff's all going into our water. Global sea levels have risen 8 inches in the past century. The rate of increase has nearly doubled in just the past 20 years and is accelerating additionally each year at this time. So you'll hear other related statistics like the last time we had this much carbon, so carbon dioxide and methane and other chemicals, the last time we had this much carbon radiative forcing, that is heat trapping effect in our atmosphere, our oceans were tens of meters higher. Was it 70 feet higher or 70 meters higher? I can't remember which, but yeah, there's a lag effect on trapping the heat, then things melt and flow into the ocean and raise it. All right, so in that scenario, Florida is literally gone. All right, 150 species a day are lost. 10% less biodiversity globally each decade as a result. So 150 species a day. At our current rates, deforestation will remove all rainforest from the surface of the planet in 79 years by the end of your lifetime. 2/3, about 65% of the Great Barrier Reef have been damaged by coral bleaching. This happens when sea temperatures are too high. Around 50% of all carbon emissions are created by the richest 10% of the world's population. So, if you make about $35,000 United States dollars per year, you are not only in the richest 10%, you're in the richest 1% of everybody on the planet. So most other folks don't live quite like us. Most other folks don't have 2-day prime shipping, and all of the fossil emissions that Amazon and related companies spend into the air to bring us our cheap plastic stuff shipped from overseas. In 19 years, the world can run out of fresh drinkable water. In 19 years. Our current extinction rate is about 1,000 times, so 3 zeros, 3 orders of magnitude, beyond what the natural baseline extinction rate is. We're good at killing things. 1 in 3 people globally does not have access already to clean and safe drinking water. So a lot of the migrant crisis stories you may have been seeing in the news, if you watch the news, are based on this. Our next wars are most likely to be fought about water and mineral phosphate fertilizers. Let's see, roughly 20% of the Amazon rainforest has disappeared just in the past 50 years. And at 22 to 25% deforestation in the Amazon, the deforestation is irreversible. It is hot enough, dry enough, and burning aggressively enough that we can't stop it and it can't regrow itself out. It will collapse into eventually grassland and shrubs. And we're right at that tipping point right now, like today. Category 4 and 5 hurricanes will increase in frequency, and we need to start adding like bigger categories for bigger storms, which is mind-boggling. All right, up to 200 million people could be displaced by climate change by 2050. So we have a few tens of millions displaced by climate change kind of today, right now. People mostly migrating into Europe from hot parts of Africa and the Middle East and so forth. We're looking at like a lot more than that. So the American border pileup of people trying to get in from Central America is largely based on political instability and by farms being so hot they just collapse. They just can't grow stuff. It's just too hot. And get ready for a lot more folks to be in those shoes. So in many cases, people are walking 4,000 miles overland to get to our southern border. All right, the 20 warmest years on record in all of human history that we know of have occurred in the past 22 years. On the upside, this was the coolest summer, I hope you enjoyed it, of the rest of your life. Okay. Let's see, 4% of mammals are wild. The other 96 feed us. Well, 60% are livestock and 36% of all mammals are humans. We are absolutely dominating our planetary ecosystems and our ecosystem support services. About 3% of the surface of the Earth we can consider natural and largely undisturbed, entirely functional. 3%. So ecologists would refer to this as what's called a population overshoot situation, or a carrying capacity overshoot situation for the human species. Let's see, 1 in 4 fish sampled at fish markets in California and Indonesia contained plastic. So, there's a couple of factoids for us. All right. So, all these things to establish that the exercises we're going through this semester, the lands that you are talking about managing, they are largely within that precious 3%. Make sense? Of more natural, functionally undisturbed land. And the targets to which we are managing this stuff, all of these different classes of resources we've been talking through at such detail this semester so far, the targets are going to change. So here we're going to pull up a map of continental United States that has been paired with climate scenario and forecasting information, and get a sense of around the year 2080, what is the climate of your particular national park's surroundings? What's that most likely going to be like instead of what it is today? Because some of those changes are going to be fairly drastic. But before we do that, we'll talk about a couple of climate cycles and forcing factors, and what tipping points are and what those look like. So, climate researchers have identified, depending on who you ask, between 15 and 25 particular kinds of planetary scale ecological processes that influence each other. They're all intertwined, and that there is no easy coming back from once we modify them with climate change and deforestation and acidifying and heating up the oceans and stuff like that. Those are called tipping points. And research suggests that of the sort of 15 most prominent tipping points we've identified as a species, 9 of those have already ticked over into no return. And each one as it goes makes it easier for the others to go. So there are some climate researchers who suggest that we are strapped on to our rocket to hell of our own making and fueling with climate and all that stuff. And one of the stats was by 2030, some of those things are going to be locked in if we don't change a lot of stuff real hard right now. So America has the National Climate Assessment. Dr. Akamane is writing a chapter for that. The Intergovernmental Panel on Climate Change is releasing its next report. Just released some good stuff. And there's a lot of good information about how these processes and cycles work. The models are amazing in how tightly they predict things now. And even so, we're still learning that we have to build in additional factors, like as the oceans warm, they melt the ice sheets in Antarctica, for example, which are very light-colored and very good at reflecting thermal energy back out into space, so it doesn't heat our planet. As we warm the oceans, it melts, it etches away and lubricates the slide of those ice sheets into that hot ocean water, and speeds up the process and reinforces the whole thing. Okay? So, these tipping points are what are called positive feedback cycles. A positive feedback cycle is one that is self-reinforcing. It's self-accelerating. So, soil erosion on a trail is a positive feedback cycle. So you get a rain event, and it knocks a little bit of soil out of your carefully built trail surface, the tread surface. And it flows to the lowest point nearby and excavates or removes that liberated set of soil, now dirt, downslope somewhere. So the next time you got a storm, you've got that scooped out, excavated area. And that channels the water a little bit harder. It's a little bit steeper. It's a little bit more like a concentrated flow path, like Williard and Schoonover research on farm fields for erosion. And then you get a third storm, and now you don't have a scooped out area. You got a slit trench that the water's going to go through real fast and channelize and carry even more. The faster water moves, the more particulate it can carry along and out and away from your beautifully constructed trail. So that's a positive reinforcement situation called a positive feedback cycle. And these tipping points are each positive feedback cycles. So for example, Arctic and Antarctic ice cover, that is one. As those get smaller, it's easier to heat up the ocean because ocean water is dark, and so sun rays hitting what used to be ice sheet and is now dark ocean, now that thermal energy gets trapped in the ocean, and it's just that much warmer to melt a little bit more of the ice sheet. So we are real close. If you haven't been following this in the global like forestry and environment research, real close to what's called a blue ocean event, where the Arctic Ocean is fully passable, navigable by freight ships, for example, instead of just by nuclear-powered icebreaker ships like it used to be. And the ice sheets, they grow each winter as more ocean water freezes back out, and then they shrink a little bit during the summer when it's a little bit warmer, and that pole is tilted closer to the sun, so it gets more insolation, or watts per meter squared of solar energy. And then the next year, with climate change, it doesn't quite freeze up as much as it did the previous winter. So it's this breathe in, breathe out, breathe in, breathe out, but each breath is a little bit smaller until it's all blue ocean instead of all big ice cap. And it was all really big ice cap back in the last ice age. Well, that's happening very, very, very quickly. It's a steep graph over the last couple of decades, not over the last 10,000 years. So that's one kind of cycle and tipping point that's in the process of happening like today as we speak. If you're aware of those absolutely stupefyingly huge tundra wildfires over in Russia, well, that blows dark, like almost black soot ash, poorly combusted cellulosic material across northern Canada, across northern Europe like Scandinavia, so it's Finland, Sweden, Norway, across Alaska and stuff like that. And now that snow and ice that was really pretty good at reflecting all that heat back up into space, now it's not bright white. Now it's kind of gray or black in places. And so it gets a lot easier to melt those snowy areas, and they heat up more and they dry out, and then you have wildfires going through. So the last several years, like 2017, 2018, for the first time in a while, we're sending lots and lots of alums, former SIU forestry folks, up to fight wildfires up in Alaska. In Alaska. Like, you wouldn't expect huge amounts of thermal loading drying out all the fuel up there enough to the point of Alaska needing thousands of wildland firefighters, and so forth. So it's pretty nuts. As those snowfields, as those ice fields, as the cryosphere retreats towards the poles, as things warm up, that warms up the absolutely enormous store of carbon in tundra soils, and that gets off-gassed as methane. So in places like northern Russia and probably in parts of Canada, although I'm not aware that they've found them yet, they have found a bunch of these lakes and ponds up in Alaska, but thousands and thousands and thousands of sinkholes, not into cave systems, but of soil that was frozen solid, now not being frozen solid and off-gassing lots and lots of methane, which is about 85 times stronger than carbon dioxide at holding in extra solar heat, and just belching it out to the atmosphere as things warm up each summer. So that warms things up, it makes those snowfields retreat some more, thaw out some more permafrost, dump lots more carbon into the atmosphere. The same thing is true with methane stored as a clathrate, or a slushy ice matrix, wrapped around each molecule of methane, CH4, in sort of shallow Arctic Ocean areas. So there were a couple of videos. There was a research ship, a climate research ship, that went across the thawed edge of the Arctic Ocean and filmed where methane is literally visibly boiling out of the water, and the methane concentrations in these plumes are like 1,000 times more than the ambient atmosphere all around. This is what climate researchers refer to as the so-called clathrate gun. There are billions of tons of methane stored in these clathrates, a slushy, icy, watery mix. And it's now starting to off-gas in the atmosphere, where it's going to heat things up even more. So, these are tipping points. Another one might be the greening of the Sahara. So the Sahara is dry and hot and very light-colored. But as we fertilize the atmosphere with more carbon and change weather patterns, a lot of the Sahara, or some of the Sahara, is going to become fairly grassy, which is darker in color than that. And so where the sun rays are hitting pretty hard close to the equator, the Sahara is real close to the equator, we're getting a lot of heat potentially trapped once that tipping point starts to happen. Okay, so all these things tip over into each other. The Sahara is the primary fertilization source for the Amazon basin, with dust storms that blow from Africa and take sediment and deposit it in the Amazon rainforest, and cloud seeding from the Amazon forcing those particles out as fertilizer. Green up the Sahara, and less of those nutrients make it across the entire Atlantic Ocean in these crazy huge dust storms and make it to the Amazon, which is also getting cut and burned so we can have cheap Brazilian beef exported all over the world. So all these things kind of tie into each other. And there's about 15 really prominent ones, maybe 25 if you want an expanded list of some sort of crack-on, follow-on effects. The ocean current that runs down along the eastern seaboard of the United States and up along the western seaboard of Africa, Europe, Scandinavia, UK, Ireland, Iceland, over to Greenland, and then back down. I guess from your perspective it would go like this. That is slowed down by about 1/6, about 15% since the year 1950. So this climate stuff is a big deal, and it's slowed down because the ice cap is melting, dumping cold fresh water into a very salty, dense, fast-flowing current, comparatively speaking, and opposing that action of that current. So the eastern side of the United States is going to get different weather as that current continues to slow down and eventually shut down, potentially, and so forth. So all of these things are kind of piling on, and there's a lot to it. There's a lot of things to synthesize, and it's kind of stressful to think about for some people. So if this is something that genuinely causes you some anxiety, I would love to help you connect with some good resources on kind of sorting these things out mentally and emotionally. But this is the landscape in which you and I are growing up in, and it is unlike anything that humanity has ever faced in the past. And what we have been trying, in like the past about 30 years, since kind of the 1990s was the second wave of environmentalism with like Captain Planet, the cartoon, and stuff like that. A lot of it clearly has not worked. Like, we see recommendations to do things like, we need to transition obviously to renewable resources, renewable energy, like solar panels and stuff like that. But everybody wants to live that American Gucci Max lifestyle, and the increase in demand as more people around the world move up to an American lifestyle and American level of energy and resource consumption, that growth is more than the growth in solar panels and wind farms that we've been super aggressively putting in lately. Our demand is still outgrowing our supply. So, this is a problem. When 1 billion plus people in China, so about 3.5 people in China for each American, we're at 300 plus million, they're at 1.2, 1.3 billion, whatever it is. When 3.5 Chinese folks in the East Beijing Plains, kind of a low-lying, flattish area where lots of people live, and their cities are an order of magnitude larger than what we're used to in the United States. That's one of the areas that's going to become extremely under pressure for fresh water and for a livable temperature. So heat waves are a non-continuous but very real threat in terms of stuff like that, right? We had temperatures that were insane in like southern Canada, and people were dying from the heat wave temperatures in southern Canada this past summer and in the western United States. It's going to be like that on the East Plains of China, close to Beijing, the capital, for a lot more people. And so countries start to get a little bit squirrely when they run out of water and run out of capacity and infrastructure to run air conditioners. Air conditioners take exponentially more energy to cool air the hotter the ambient temperature gets. So we're looking at bringing folks down to a survivable temperature below 95 degrees, 100% humidity, so that folks aren't dying from heat exhaustion and stroke, but spending exponentially more energy to do that versus 50 years ago when air conditioning was first starting to become a thing in the first world. Okay? India and Pakistan are nuclear armed, and they are constantly fighting over the last fresh water in the border valley between them. And it's kind of anybody's guess when that pops off into full-blown actual war over water. In the western United States, we're in a historic drought, and we're about to tip over into the 89-year Dust Bowl drought cycle that we talked about just briefly at the beginning of this semester in this class. So, our current targets, our current understanding of what your park is, need to be reconciled against our best guess, our best understanding of what conditions are going to be like at the tail end of your careers. So we have a reasonable and sane and well-informed, well-based, well-resourced set of ideas on what's even possible for park management. Okay, cool. So the last set of stats we're going to toss out for this bit of climate depressing news are translating what some of those temperature change numbers mean in terms of lived experience for you and me and everybody else. So, has everybody heard of the Paris Climate Accords? All right, so the function of the Paris Climate Accords was to set some targets for countries. Basically, trying to emphasize that, if we all, as different countries, do our part proportionally relative to our emissions, being part of the problem, if we all contribute to the solutions involved, then we can hold global average climate change and all the destabilizing effects to below what number? Does anybody know? Like every couple of years, these big reports, these big conferences come out and lots of sound bites and stuff like that. Does anybody know what the world is trying to accomplish in terms of a target for climate change?
Like less than 2 degrees centigrade?
Yes. So 2 degrees centigrade above average, above pre-industrial average, is considered extreme risk for the collapse of human civilization. 2 degrees Celsius. We're at like 1.2. so far. Less than 1.5 is what countries are submitting plans to try to hit. So if we're locked in, carbon dioxide, for example, has a half-life of close to a century in the atmosphere. So the carbon that my parents emitted driving to the hospital on the day that I was born is about halfway through its life too, and is still heating things up a little bit. So even if we all, stopped emitting carbon and stuff like that as all of our different countries and magically just pulled that off, we'd still have 30 or 40 years of warming up, but, the curve kind of flattens out and then starts to actually going back down before the year 2100. And in order to do that, countries have to basically cut their carbon emissions in half by like 2035, and carbon equivalent emissions, so things like chlorofluorocarbons and methane, also contribute to what we have to stop doing. If we get halfway to carbon neutral or zero carbon emissions equivalent by about 2035, and then all the way to carbon neutral or zero net emissions by the year 2050, we have not the guarantee, but a reasonable shot at holding climate change below 1.5 degrees Celsius total. And storms continue to get worse, droughts continue to intensify, wildfires continue to spread for the next 30 to 40 or 50 years. And then things kind of get back to the garden earth that your early ancestors and mine got to enjoy. A regular, stable, very livable climate in most places. We're not hitting those targets right now. And when you kind of sum up the total emissions that are happening and then also start including some of the, like those methane clathrate and permafrost melting methane emissions and ocean acidification, stuff like that, we're tracking right along with the so-called business as usual or worst case high emissions scenario. And that scenario, instead of the, hold it to less than 1.5 total change, according to a study that came out earlier this week, has about a 10% chance of putting us at 7 degrees global average warming, which is enough to remove human civilization from the face of the planet many times over, lots and lots of times over. So that's a little scary. If your car seatbelt had a 90% chance of working, you probably wouldn't use your car much at all, ever. Well, our planet is facing that particular set of odds, and there is no planet B, right? As the saying goes. So, some countries are doing awesome stuff. The major, like the big 6 or 7 emitters of carbon, including the United States, are not, and that's an issue. So, you and I did not ask for this context, this situation, but we are in it, and we are called to be foresters and human citizens and hopeful survivors of all this stuff, despite the fact that we didn't really choose it. But here we are, okay? So, this is super downer. So let's pause here for a sec and stretch our legs, and let's kind of maybe answer any questions you guys and gals have. And then we'll start using some climate modeling tools and data products to figure out how to manage your national park this semester in the face of what's happening in the near future. All right? Cool. So take a quick break, stretch your legs. help me calibrate our discussion coming up as we're relaxing here for a sec. To what extent or what direction are you guys talking about climate change and destabilization in some of your other classes, inside and outside of forestry? So, to what extent are you guys and gals talking about climate change at like a functional technical level of detail in your other classes? I don't want to like go back over stuff you're hearing everywhere else, if that's the case. Okay.
Talking about it too, yep. Yep.
Are those probably environmental studies minor? Yeah, right on. Cool.
Environmental sustainability.
Cool. Hang on to your butts. It's gonna get wild.
Oh
The Professor Leslie, who teaches and leads the environmental studies minor, is organizing a climate teach-in in the spring. I think that's pretty cool. Just to help more folks think about it, talk about it, and start making some changes.
Say climate teaching.
Teach-in.
Teach-in.
Like a
Okay.
kind of like a protest, but one that doesn't screw students by like a bunch of bitchy professors like being like, oh, well, I'm protesting something today, I'm not going to teach. So you just kind of hijack the regular curriculum and talk about climate stuff. All right, about ready to jump back in? Cool. Okay, so in our quick break, pretty much I heard that talking about climate change like all day, every day in some geography classes, environmental studies classes. What about other classes? Inside or outside of forestry? So this has a lot to do with forestry. For example, just recently, for the first time, wildfires west of the Sierra Nevadas, which, if you speak any Espanol, means snowy mountains. Wildfires were for the first time able to cross these snowy mountains and start burning stuff on the far side of the snowy mountains, which should be a pretty good fire break if you think about it, right? But with the Sky Island effect of things warming up and pushing stuff, pushing habitats off the top of mountains, it kind of changes the premise of wildland fire management within forestry when it can jump farther and jump across big natural fire breaks like literal entire mountain ranges. For water management as well, this is a huge deal. So if you're a forest hydro person, right, California grows like 40%. Sacramento Valley, Imperial Valley grows 40% of all American food, and they are super out of water, like in a big way. Like a lot of rice is grown out there, and half the fields this year are just dry. Let's see if we can pull up the drought map here. There we go. So I don't know if everybody can see this. I know we're outside and it's a lot of glare, but here is a global wildland fire probability map for the near future. And the red symbology on this map is percent positive change in likelihood and severity of fires. So one of the most red spots is the Amazon basin. Okay. The Amazon has a lot to do with regulating global water cycles and global air cycles too. So about 1 in 5 breaths of the oxygen that you and I really enjoy breathing. Side note, oxygen is a euphoric, which is why people go to oxygen bars to get very slightly high breathing pure oxygen with flavors. It's like vaping without the popcorn lung. Pretty cool stuff. Anyway, about 1 in 5 breaths come from the Amazon, and it's not going to be able to supply us those breaths, especially if it lights itself on fire in the next half century here. So yeah, this has some real consequences. And here in the American West, we do water management with this just arcane, outmoded water rights regime. It basically, if you're downstream from somebody else, you kind of are at the mercy of that person taking only their allotment of water. And in a lot of places, those water allotments are not adjusted for, droughts like we're in the entire American West right now. Yeah, drought maps are just out of control right now. And they're most likely to get worse instead of better, because a lot of our agriculture is propped up on fossil water that we're pulling out and can't put back into those aquifers. As the water's sucked out of the pore matrix of bedrock, that sort of open, dry, spongy bedrock compacts down under its own weight, and the aquifer goes away permanently. It just subsides. So in Mexico City, where they're doing the same thing, they add stairs onto the bottom of public monuments and buildings and stuff like that as the ground literally compacts away from the surface of the earth. It's bizarre looking, but it's just slow enough that people don't freak out about it. It's that whole frog boiling thing, you turn up the temperature slowly and that's how you get them. Kind of a dynamic. All right, so take a minute to let your mind's eye wander across your map, your understanding of your group's national park this semester. So, climate change is not evenly distributed in time or space with respect to heating, with respect to ocean level rise, different parts affected by different currents and different inputs of melting glacier and ice shelf ice. There's a lot of slosh in the oceans, for example. So not all places get the same rate of sea rise as all others. So we want to start asking some questions. What's the situation around your national park? If you're a landlocked park or a West Coast adjacent park, you're probably not worried about sea level rise because the cliffs in California are pretty high, and the oceans are going to rise eventually to overtop some of those cliffs, but it's going to be long after we're gone, and if it actually gets to that point, then society's already collapsed. If you're an island national park like U.S. Virgin Islands, then maybe you need to think a little bit more about that whole coral reef side of things and the bleaching and what's that's going to do for the ecosystems that are largely dependent on those coral reefs. Something like 90% of marine species have some connection or dependence on coral reef habitats for fisheries and so forth. So marine protected areas, some run by the U.S. National Park Service, are a huge tool to even be able to do anything about that, to even know that it's happening and to what extent and why, and to figure out the mechanism and so forth. So we are at the leading edge of being able to do something about any of this stuff, while some other folks in politics and technology and genomics do things like fund and figure out how to grow climate change resistant rice that feeds half the entire planet calorie wise. Literally half the planet needs rice or they will starve to death, right? And a subset of folks in the United States are in that boat, okay? So we can genetically engineer rice. We've done it before, we'll do it again, right? Golden rice is a thing that adds necessary vitamins and helped fix some serious malnutrition problems across sub-Saharan Africa and all throughout South Asia. But the question is, do we have stable enough growing seasons going forward? Do we have regular enough water inputs to rice paddies to be able to continue to grow that much rice? Oh, and by the way, we need to double our food production by about the year 2050 with rising populations and so forth. So in a time when our capacity for growing calories and nutrients is starting to drop in a lot of places, the demand is still going up. And when those lines cross, we're going to see big time wars, big time starvation. People are not going to be cool with that, obviously. Okay? So what is your national park kind of staring down the barrel of in regard to changing wildfire risk? What is your park staring down the barrel of in terms of getting absolutely plastered by intensified hurricanes and tropical storms? So back when I was a kid, Hurricane Hugo was a huge deal because it was like this once in a couple of decades thing that smashed into the southern coast, and everybody was like, I can't believe this happened. Where did this storm come from? These days, we basically kind of bank on, or we expect to have a couple of catastrophic hurricanes, category 4 or 5 type things, hitting not just the United States per season, instead of once every 20 years or whatever, and really doing some damage, but the same section of the coast hit multiple times. So those people that died in New York City from the most recent hurricane, that was the second one to hit that section of the coast of the Gulf, and then it went over land, but it still had enough steam in New York to flood a bunch of basement apartments and kill people, right? So that's how climate change, or one way in which climate change kind of threatens us. Is your park in the current or expanded kind of flight lanes for hurricanes? The city of Tokyo, a megalopolis, there are 25 million human souls living in the Tokyo metro area. The greater New York City area, including parts of New Jersey and stuff like that, is 25 million. Tokyo, even bigger than that. It got hit twice in a row by hurricanes in the space of a couple of weeks last year. That didn't used to happen. Now it does. And we're not done expanding the aggressiveness of storms due to climate change today, right? We're strapped in for at least 30 more years of increase before things start to go down under the best case scenario. So, what is your park looking at in terms of storms or changes in precipitation? So, some of these are pretty easy questions, like U.S. Virgin Islands. Yeah, we're going to worry about some hurricanes, okay? But there are some things we can do to ruggedize our structures and our trails and our roads and stuff like that versus additional hurricanes. That's all right. We spend that money, we bite that bullet, and we take care of it, we get it done. And we move on. For some of the more detailed questions like, how's the precip pattern going to change? How's the climate going to be different in terms of basic assumptions that we don't generally even think about much, like timing, amount, frequency, intensity of useful rain, like low intensity storms that water our fields instead of eroding 6-foot gullies like we used to get in southern Illinois during the last Dust Bowl. So we have some good tools for this. All right, I'm going to pull up a map. Let's see here. This was a data product out of a recent climate change study that took current settled places in the United States and took climate model information and found the most comparable climate conditions of cities 60 years from now versus what they would be like today. So, for example, when I put Southern Illinois, Carbondale, and I click that on the map and go with the most similar climate under the, as best we know, we're sticking with our high emissions, business as usual, aggressive fossil fuel, fossil water use scenario. And the result gives, for high emissions, Carbondale's climate in 2080 will feel most like today's climate near Monroe, Louisiana. Inland Louisiana. So that's like a 50% wetter winter than we're used to, and a 3% drier summer, and a 5 degrees Fahrenheit warmer summer. So pushing us into occasional fatal heat wave range here in Carbondale. Like, don't go outside this afternoon, you will die. And about 15 degrees Fahrenheit warmer in the winter, on average. So, where in southern Illinois and a lot of places like this in sort of the southern Midwest, we depend on occasional hard freezes to knock back forest parasites like what? What do we really hate that cold, hard snaps take care of for us in our forests? Any forest pathogens or parasites that you're aware of from Forest Health, maybe? Ticks! And various kinds of bark beetles, as also out west, and so forth. Without those hard freezes, because our winters are 15 degrees warmer on average, we're getting into not hard freezes coping territory, we're getting into, why do we have thunderstorms on Christmas Day and lightning storms on Christmas Day? Like, there's that much thermal heat energy in southern Illinois in 2080 to do that. That's not how we grew up, but it's what we're careening towards. All right, so give me the nearest city near your park, and we'll get a sense of what the climate's going to be like under, as best we know, current emission conditions and so forth. So, anybody, holler out the town closest by. Seattle, Washington. Seattle, Washington will, in 2080, feel most like today's climate near, this is not the same Milwaukee that you know, this is Milwaukee, Oregon, spelled differently. All right, so the typical summer in Milwaukee, Oregon is 5.5 degrees Fahrenheit warmer and 23% drier than the summer in Seattle. Seattle's in that sort of northwestern temperate rainforest regime. All right, cut that precip level by 25%-ish. That's a drastic change. Does that knock it out of temperate rainforest into like western forest, temperate mesic instead of hydric? Maybe it does. Okay. Cool. Let's see. All right, who else? Washington, D.C. The line's really long on this one. I don't know if you can see that. All right. For high emissions, Washington's climate in 2080 will feel most like today's climate near Greenwood, Mississippi. That is 9.8 degrees Fahrenheit hotter in the summer and 75.2% wetter than winter in Washington. Okay, so not quite doubling, but kind of close, the amount of precip that DC gets in its winter. Are you guys aware of any flooding impacts or damages or concerns with C&O Canal National Historic Park relative to the Potomac River being highly channelized with 80-foot cliff walls in the lower section? Would adding 75% more water be an issue? You're gosh diggly darn right. Yeah, okay. So big change. How do you change the management goals or approaches, like the day-to-day techniques of C&O Canal National Historic Park, if you know that the biome is going to be more like, if you know that the climate is going to be more like Greenwood, Mississippi than DC? All right, anybody else? Who else? Anybody here for Isle Royal? Minneapolis. I'm glad you asked. Wow. All right. Wow. For high emissions, Minneapolis-St. Paul's climate in 2080 will feel most like today's climate near Lansing, Kansas. If you've been through Kansas and you've been through the Twin Cities, Minneapolis-St. Paul, they are not like each other. Not even a little. So, the typical winter in Lansing, Kansas is 16 degrees Fahrenheit warmer and 38.5, almost 40% wetter than winter in Minneapolis, St. Paul. Okay? So, think about forest operations, like traditional resource forestry operations through the winter in a place like Minnesota, where the assumption was, man, this used to be a cold, brutal winter. Well, winter in Kansas is also tough, but it's not central Minnesota tough. So Lansing, Kansas is right outside of Topeka, to give you a sense of that. Anybody else? Nearest town or city to your park, if we haven't got yours yet.
St. George, Utah.
St. George, Utah. A wonderful place. Let's see. All right, we're gonna have to go a little bit east to Grand Junction, Colorado, which isn't exactly the same, but it's pretty close. So, for high emissions, Grand Junction's climate in 2080 will feel most like today's climate near Sunrise Manor, Nevada. That is 15.7 degrees warmer and 45.5 degrees and 45.5% drier than wintertime in Grand Junction. I mean, almost 50% drier in eastern central Utah or western most Colorado. Like, it's not like Colorado has problems with wildfires, with emerald ash borer and pine beetles and all sorts of stuff, right? So cutting their precip in half, not a problem. Except that it would completely rewrite that entire ecosystem to look. So Sunrise Manor is just outside of Las Vegas. Okay? So transforming western Colorado, eastern central Utah to look like southern Nevada, the desert, big, major, complete renovation of those ecosystems. and the people trying to live nearby, like you and me. All right. Anybody else? Did we get them all? Say again? Dickinson, North Dakota. All right. Climate change is going to take that down to the southern South Dakota border with a summer 7.1 degrees warmer and 22.8% wetter. So quite a bit more precip. So in the eastern half of the United States, the game basically boils down to up to 15 degrees hotter, which is getting lethal during heat waves, right? This is conditions we'd expect to kill other people elsewhere, but now it's us. It's coming home to roost. And significantly more, up to almost 100% more precip, usually in the wintertime, in terms of sort of gross weather pattern changes. For the western United States, things also get hotter, but not quite as hotter, usually like 5 to 10 degrees hotter Fahrenheit, and then typically drier. So hotter and drier versus an area that's already in extreme, like precedent-setting drought. Here we go. Okay. Pretty different. All right, so any questions on that?
I'm just kind of curious, like the colder areas, like Wisconsin area, what would be an example?
All right, so
Or Michigan, Minnesota.
Green Bay, Wisconsin is going to have the climate of Cincinnati. 6.2 degrees warmer in the summer and 5.5% wetter. So, pretty different.
Can you try the Caribbean just to see what it like? It's Cruz Bay, C-R-U-Z Bay.
C-R-U-Z Bay. Looks like they don't give us anything for territories. Yeah. Best I can do is Miami, Florida. Kind of close, not really, but it's fairly dramatic. All right, so Miami's climate in 2080 is going to be most similar to San Blas Atempa, Mexico, south of the Yucatan. So that's 11.3 degrees Fahrenheit warmer on average and 91.5% drier in the winter. So that's like a collapse of the monsoon pattern, the winter rains. So tropical areas need a lot of water because nutrient cycling is super aggressive. It's easy to get nutrient depleted soils in very hot tropical temperatures. So as we heat it up more, that's gonna wash out all those nutrients for all the species trying to grow at U.S. Virgin Islands. And if there's a greater than 95% cut in precip for that area, at least through the winter, well then, shoot, that's a complete replacement of the ecosystem present. So the practical question to us, and there's not a single answer for this is absolutely what Dr. Akamane will refer to as a wicked problem. Problems that are generations spanning in their time scale, planetary and human civilization scale in their side effects or main effects. Crazy expensive, with not a lot of necessarily immediate or direct benefit to the people who have to solve the problem, and so forth. So the question of where do you aim your national park management towards, knowing that this is, as far as we can see right now, with measuring emissions and watching politicians not do that much, and capitalists doing a lot of things to incentivize even more aggressive resource use. where do we go from here? Okay? We're going to spend the rest of our semester pulling that question apart and seeing if we can come up with some good answers. Now, if that's a hard set of questions to answer, that's okay. I don't know all the answers to that question, and none of us is really supposed to yet, but we got to figure this stuff out, okay? So we're all going to figure it out together as we go, because we have to. Cool? All right. What questions do you guys and gals have? What things are confusing about climate forcing? We're obviously glossing over quite a bit of stuff. What would you like to hear more about? What would you like to brainstorm about your particular park? What questions do you have? So this is a good, this is horrible and cynical, but this is also a good moment to think about, all right, so with the Forest Service and with the Park Service, other federal land management organizations, it's very common to kind of, bounce around between a couple of different spots, working temp seasonal positions, getting federal standings, some federal experience. We talked about that the other day, talking about resumes. This is a good prompt or reminder or opportunity to give yourself permission to work all over the country for a couple of years before you settle down somewhere, maybe closer to home, family, friends, stuff like that. Because by the time you retire, you may want to have a more detailed familiarity with other places in case you need to move somewhere. People are already going into the hospital and dying at a measurably higher rate in places like southeastern coastal Georgia, where the heat and the humidity are so high, it's approaching that sort of early organ failure, occasionally lethal level. And even just 5 years ago, this was a thing that folks were only starting to come to grips with in southern Central America. Like, why are all these farmers just abandoning their farms and migrating north? Oh yeah, they can't live there. It's starting to show up around here too. So let this be a good option to, maybe move north. I don't know. Start stockpiling bullets or something. Be a paranoid prepper. No, I'm kidding. Mostly. But, right? We are going to be managing forests all over the country to help corral these problems, planting our portion of 1 trillion plus trees to try and sequester some more carbon, busting up olivine-rich rocks and spreading them on tens of thousands of miles of tropical shoreline to sequester more carbon using wave action. People are talking about blasting aerosols into the stratosphere, simulating volcanic eruptions to reflect more sunlight to dim the sun across the entire planet, and who knows what that's going to cause. This isn't all hands on deck kind of a thing. And managing our parks is a pretty good proxy for how we're going to survive in managing everything else. Because, if anything, we have the easiest time in parks. We have the clearest reference points in parks as part of that 3% remaining natural space on the surface of the earth. That's not farms or, watershed catchments for urban consumption. It's not urban heat islands, whatever. 3% left. So if we can figure some of these things out for parks, we stand a pretty good chance for figuring them out for cities like Atlanta, megalopolises like the greater New York City area, and Tokyo and its outlying cities, and the cities of 50 to 100 million residents in parts of China. Stuff like that. Cool? All right. And a lot of it comes down to forestry. That's pretty sweet. So, yeah. So now that you've had a second to noodle it over, any questions? All right. In that case, let's actually end a little bit early and use this extra time, hopefully, to take a look at your park, take a look at your notes for how much hotter it's going to be or how much drier or wetter it's going to be. I'll see if I can't post a link to that map so you can kind of look around for different equivalent modern day temperature and precip regimes versus in 2080. They give you a couple of different choices for like low and high emissions and different ways to display the data. So if this was at all confusing to you, ask some questions now, take a look at the map later, and we'll start getting a sense of what's going on. Now that we've had a chance to start talking about some of these interaction and moderating or exacerbating effects of things like climate change, our next move is to flip over into the middle half of the semester, talking about kind of the human thought processes, humans as recreationists, humans as using forests for things including recreation, and how we tend to behave in characteristic ways and kind of what to do about that as a whole other set of human-based interacting factors. Cool? All right. I'm around for questions for here for a bit if you need. Otherwise, have an excellent weekend. If you're coming canoeing with me, pack your rain gear. And otherwise, we'll see you on Monday. Cool.